let's do an example for uniform circular motion. So we have Top Gun pilots have long worried about taking a turn too tightly. As a pilot's body undergoes centripetal acceleration with the head towards the center of curvature, the blood pressure in the brain decreases, leading to loss of brain function. There are several warning signs. When the centripetal acceleration is 2g or 3g, g being 9.8 meters per second squared, the acceleration of gravity, the pilot feels heavy. At about 4G, the pilot's vision switches to black and white and narrows to tunnel vision. If that acceleration is sustained or increased, vision ceases, and soon after, the pilot is unconscious, a condition known as G-LOC, for gravity-induced loss of consciousness. What is the magnitude of acceleration in G units of a pilot whose aircraft enters a horizontal circular turn with a velocity v initial of 400 I hat plus 500 j hat meters per second, and 24 seconds later leaves the turn with a velocity v final of negative 400 I hat minus 500 j hat meters per second. So let's draw those velocities first, because I know we're given it in unit vector notation, but here we're talking about circular motion. So I want to know what's happening with the velocities in magnitude angle form. So I know the initial velocity has a positive, that's a terrible, terrible line. It has a positive x component and a positive y component. So there is my resultant vector. Oh my goodness, why can't I draw today? That's my resultant vector there for the initial velocity. So I have v initial y and v initial x right there. And then for my y component, my final component, I have a negative 400 and a negative 500. So there is my final, v final. This is v final x and v final y. So I can see if I draw that circle right here, it's moving in circular motion. This right here is going to be my v initial. See this vector right here. And then this right here will be my v final. And those are the same magnitude of vector because, again, we are going at uniform circular motion, which means it's a constant speed, but they are opposite in direction. And we can see that because, well, number one, from the picture, and number two, because the initial x component and the final x component are same magnitude but opposite direction. The initial y component and the final y component are same magnitude, again, opposite direction. So that's what we know so far for that. And then also we can find the velocity. So initial velocity is going to be equal to final velocity, and that's the magnitude of the resultant vector. And that will just be the square root of 400 squared plus 500 squared. So initial velocity, which equals final velocity, will be equal to 640.31 meters per second. Okay, so remember, this is the same magnitude of velocity for initial and final, but they are in opposite directions. So we have velocity now. So the question is asking us for the magnitude of acceleration in g units. So if we look at the acceleration equation, we get acceleration is equal to v squared over r. And remember, this is centripetal acceleration because we are moving in a circular direction or circular path. So we know velocity now, but we don't know radius. So in order to find that, we have to see what else we're given. Now it says that 24 seconds later, it's going at that final velocity. So what that tells us is that from here to here, which is half of our path, that is 24 seconds. So that means a full circle would then be 48. And remember, the time for one full revolution is called period. All right, so they're giving us period with that information. So from that, we can then find our radius. I am actually going to get the radius in terms of everything else, just in equation form, and plug it into acceleration. So I know that velocity is equal to 2 pi r over period. I think I gave you this equation, but just solving for period in the actual notes. But remember, this is a constant speed, and constant speed is equal to distance over time. The distance that we travel in a circle is the circumference of the circle over the time for one complete revolution, which is where this equation comes from. So if I solve this equation for radius, I get radius is equal to velocity times time period, sorry, divided by 2 pi. I'm then going to take this and plug it in for our radius here. So I get acceleration equals v squared over v times time divided by 2 pi. One velocity cancels out here because we have velocity on the denominator, and then that 2 pi, since it's the denominator of a denominator, it then flips up to the numerator. So this becomes v times 2 pi divided by period, and then we can plug in our information. Our velocity is 640.31 meters per second times 2 pi divided by the period, which is 48 seconds. So for acceleration, we get times 2 times pi divided by 48. We get 83.82 meters per second squared, but remember we want this in G's, so we have to divide this number by 9.8 meters per second squared. So if I divide this number by 9.8 meters per second squared, I did 8.9 for some reason on my calculator, divided by 9.8. We end up getting 8.55 Gs, which is a lot, right? They were just talking about how they'll like get gravity-induced loss of consciousness soon after 4 Gs. So that's not good. That's the magnitude of acceleration in G units.